Alright, this is my second time recording this because the first time I fucked up. I was talking to myself for like 5 minutes. Anyways, the first thing that you have to do in this problem is you've got to look at your HMIC. And we can tell that the plus there is at the 1 there, so we know that HMIC equals to V1 minus V3. Because it's just like any voltage source, H equals that. So you got to just think of it as a voltage source, and we don't know what the voltage is because of the current, so HMIC equals V3. V1 minus V3. Now the second thing you look at is your short circuit constraint. So that's your voltage source constraint. Now you say short circuit constraint is just over here, so where the 1 and 2 is. That just means that they're the same current, essentially. So V2 minus V1 is 0, and equals 0. The only reason why I do it like that is because that it's going to let the currents flowing this way, so then that's what I just do it like that, because I don't know if there's a correct way or if there's any science behind it, but it works for me like that, so I'm going to do it like that. So yeah, so that's your first equation, that's your second equation. They're both very, very important equations. In fact, that's your that's already one equation that you put straight into the solver. And then now what you got to do is you got to do KCL at this point. The reason why you do it here is because you got no HMIC there, and you'd rather not have HMIC, or it's going to really fuck you up, because then you're going to have too many unknowns. And the whole point of it is to actually get IC itself. So you need sorry, no, you don't need IC in this one. The next one you need IC. So the whole point is just to get those three nodes, that node, that node, that node, without IC or HMIC there. Now, well, basically what it is literally just G1, V1, and then you've got I minus I3, but we'll just put that in. So plus G2 V3 equals to minus I1. And that is equation number 3. So you've already got your 3 equations, and you need one more equation to find out what IC is, and that's just not something that you put into the solver. That's just something that you just need to know, or basically a trick or manipulation to find out what IC is. What you've got to do now is you've got to do nodal at point 0, or V0. Sorry, V2. We've already done that. So that's KCL at 0. That's going to go to KCL 2 because we've got IC there, and we'll need IC to be the subject. So if we do it, just do KCL there, you've got IC, or how about just put in the end? So, oh no, fuck it, we'll do it now. So I go step by step. So we go IC plus I1 plus G3 of V2 minus V3 equals 0. Now we could just bring IC over, but it'll be just a bitch because it'll be a minus, so it'll be a bit confusing later on. So as long as we'll just keep it positive, we'll just move everything over to this side. So then we'll have IC plus IC equals to I1 plus G3 V2 minus G3 V3. We'll just expand because it'll make it easier when we do the actual equations later on. Okay, so that equals IC, and we need to find out. So now we've got what IC is, which is up here, the equation that we need to put into. Yeah. I think I forgot to say this, but that's already the first thing that you put into. So this is your number one thing that you put into your what is that thing called again? The equation solver. Then that's your second equation that you put into the equation solver, and we're just doing the last one right now. So what it is, you got to put that into that equation. So V1. Is that even recording? Oh yeah, just. So you got your V1 minus V3. Oh, yeah, minus V3 equals to HM multiplied by I1. Oh, it's supposed to be minus I1. Whoops. Minus I1 plus, what was it? Minus G3 V2 plus G3 V3. That's my fault because that's meant to be a minus, that's meant to be a minus, and then minus times that is minus, and minus times that is plus. Am I wrong? Yeah, I'm correct. Now, it's all fun and games, but you still have V2 and V3 on this side, and you bring them over to that side. So what you got to do is HM, multiply everything by HM in there. So you got HM minus I1, and you got HM, then minus HM G3 V2, and you got plus HM G3 V3 equals to V1 minus V3. And then it's literally just bringing all that to the other side. You got your V1, which is just 1. You got your V2, which is G3HM or HMG3, which is right there. That becomes a positive as you bring it to the other side. And then you've got your minus 1, because you've got that minus 1 there, minus HM, minus G3HM. So I think that's even just a positive G3HM on the other side, but it's just going on what the actual symbolic answer is on WebTutor. So your thing should look like, whoops, let's just go. Your actual equation should look like from here. Go here. You got G1, you got 0, and then you got G2 equals to minus I1. And then for the second one, you've got V2 minus V1, so you got minus 1 here, you got minus 1 there, 0, that equals to 0. And then HMIC, you've got your 1 from 1V1, you got your G3HM, your V2, so HMG3 G3, and then you have your 1 minus 1 minus G3HM, and that equals to minus HM I1, so HM minus HM times minus I1, excuse that. Yeah, and excuse my handwriting, but if you could just look at there, shit, I'm not sure if it's in the screen, but that is the answer right there. Easy.